Alright, here we go. Let me switch this. There we go. Switch over to this. There we go. Hello, hello, hello. Good afternoon / morning to everybody. Hello. How we doing today? How are we doing today? Khadija, good morning / afternoon. How you doing today? Doing all right. All right. Very good. I'm doing very good on this fine Wednesday. It's already the middle of the week, so shorter week this week, just by a single day, but not too bad. We're plodding along really quick. Today, I honestly think today will be a quick day. So, I think today will be a quick day, question mark. But we'll see. We'll see how fast things go. I don't know. But you know what? We're going to try stuff out. See what we get. Magic happens. I wave my hands. Things go on. Okay. You know? and then math happens. And then I just wait for the money to come into my account. This magic amount of money. Hey, Goldmash, how you doing, my friend? Okay. Should have. Okay. Goldmash, how we doing today? You good? All right, good. All right. You ready to watch England Denmark today? Some England Denmark coming up in a couple hours. I know that you're not rooting for either team here, but probably rooting for Denmark since you're not a big England fan. It was a pretty exciting match between Italy and Spain yesterday, so should be a pretty good match to watch England and Denmark. I did. I did see your whispers there. I did see what you wrote there, so don't worry about it. It's fine. Let's see, what do I got here today? I got a few drinks here today, by the way. So let's see what I have here. I have let's see, Starbucks Frappuccino. Yeah, that's what I got here. I got this Body Armor Edge stuff here. Got some Gatorade with caffeine. I wanted to try that out, see if that was any decent. And of course, I have just plain Jane water in a big old tub. Yeah. There we go. That's my hydration for the day. I got 3 possible drinks. That's what's going on, for sure. What are you guys up to today? Any plans for today, everybody? You guys gotta let me know. What's going on here today? Got a few people here in the chat. It's actually pretty good. Yes. Oh, okay. 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 I'm going back to sleep after this. What did you do yesterday, Khadija? Hey, Brian. Hey, Nicholas. Hello. Good morning / afternoon. Brian, good morning / afternoon. How we doing? Hopefully we're doing absolutely fantastic today. He's like, gonna go to bed. England versus Denmark for me. Yeah, me too. Couldn't sleep till 4:30 a.m. again. Oh man. Oh, what's going on? It's just like you have a lot of energy, or are you eating late night, Taco Bell? I mean, I don't know. You're like, you get me some bean burritos. You're like, here you go. Everybody's got a thing. Hey, Jess. Good morning / afternoon to you. Hopefully you're doing fantastic. Well, everybody's doing fantastic first and foremost. Nicholas, what's the plan for today, my dude? I gotta know. Any plans for today, Brian? Any plans, or is everybody gonna go to sleep, or is everybody just gonna sleep in my class? I don't know which one is gonna happen. One of those 2 things will happen. Either I really can't just sleep. I could wake up at 8 a.m. and not be able to fall asleep before 3. Okay. Do some math, finish the homework, then not sure. Hopefully just hang. Very good. Brian's working today, heading into the city. Alright. Doing good, how are you? I'm doing good. Absolutely fantastic. Absolutely fantastic. I've been reading, actually. I've been reading a lot about the big story going around here is that the Bears, the Chicago Bears, may move here to Arlington Heights, or by the old Arlington racetrack. So, which I think is a great idea. So, I think that's a great idea. Yeah, look, I'm all for that. I'm people who I've been to. Look, I've been to Soldier Field before, and trust me, don't get me wrong. Soldier Field is nice, okay? It's a nice stadium. It's not the same after they redid it. They don't have as many seats as other teams. And the fact is that the parking is a nightmare in and around Soldier Field. Like it's already tough around that area just because of people who go to like Shed Aquarium or stuff like that, or go to the Millennium Park. And it's already super expensive. So I'm like, well, you could make more money just by charging for parking around that particular location. The Metro runs exactly by the Arlington Raceway right now, and it's right on. It's easy to get to. I mean, you'd have to do some expansions for the roads around there. I'm familiar with the roads around there. They're not, you'll have to, of course, repair the roads and maybe make it 3-lane instead of 2-lane, whatever you want. But it's actually pretty easy. I mean, if you need to house 70,000 people for a stadium, I think that's pretty doable in an area like that. People say it's not doable. I beg to differ. There's a lot of space on that racetrack. The racetrack is pretty large, so I'm pretty sure that you can say. White Sox is supposed to take over Soldier Field? Wait, how is that even a thing? How are the White Sox going to play in Soldier Field? Soldier Field isn't even made for baseball. I'm confused. I mean, if it's the Chicago Fire play in Soldier Field. They're going to rebuild it. The Chicago Fire play in Soldier Field. So what you're saying is that why would the White Sox aren't in the greatest location by far. I get it. They're on the south side, but they are the South Siders for a reason. So, rebuilding that stadium in terms of baseball would be really difficult. The football team, the Chicago Fire, definitely already play there because they moved from their home in where, like Naperville? I think it was Naperville. They moved back to Soldier Field. Yeah, so it's actually rather interesting. It's actually rather interesting to hear about like the possible business moves. And the fact of the matter is, inner city taxes are already pretty crazy. So I mean, if you go out to at least a suburb of Chicago, it might be a lot better. Yeah, it's a further drive from inside the city, but at the end of the day, I think it's cheaper for people. Definitely cheaper out in Arlington Heights than it is in downtown Chicago, that's for sure. That, and you don't have to get charged like 20 bucks for parking. Parking is stupid, man. Inside the city, parking is so bad. Parking is so bad. All right, E-Man, I gotta ask you, my fair lady, I gotta ask you, which are we hydrating here today? I got 3 drinks. Okay, I got today for hydration. I got 3 drinks I picked up from the gas station not half hour ago. So I got this body armor stuff here. Okay, that's the kind of Gatorade with caffeine stuff. I have the Starbucks Frappuccino. Okay, just the little bottle. Pretty sure you've probably seen this one before. And then I got my big old jug of water that I just had on stream just not a second ago. Alright, so there you go. So you get to choose which one you would like me to drink, and I will drink that one. Want water? Okay. Hydration king. It is pretty hot out. I'll probably melt like a popsicle and probably sweat off like 3 pounds with my fat butt. Hey, Lysidetta. I like the fact that there are options. So today is a special options for hydration. I decided to go to the gas station, about half an hour ago. So decided, spice it up a little bit. Have a little nice time. Everybody gets a chance to have their say. All right. So let me go ahead and do some intros. We're gonna do some intros here. We're gonna get started. We're gonna get this thing going. All right. All right. So let me know if the music's too loud. I'll turn it down. All right. Let's do some intros. Today will be a nice day. I think today will be an easy, simple, rather simple day. And we'll get things. Okay. Let's do this. All right. Okay, let's get started today. Welcome back to Wednesday. All right, so we're going to pick up where we left off last time. Last time, ladies and gentlemen, we finished up Chapter 5. Chapter 5 is done and dusted. We talked about the exams, talked about all this stuff. All right, today we're moving into Chapter 6. Okay, so Chapter 6 is the next part of what we're doing here now. We're going to pick up where we left off from the last handout, which is specifically the second question here from the last handout, which will reflect section 6.1. We're going to go to the big board here, and today, by the way, as I mentioned here at the end of class here last time, we are going to use the calculator quite extensively here today. So today is pretty much going to be calculator day, okay, in some regard. So let's go ahead and do it. Let's see what we're working with. Yay. All right, perfect. Okay, so let's take a look at number 2, which is from the last handout that we looked at here last time. Number 2 says, what is a matrix? All right, so a matrix is a representation of a system of linear equations. Okay, on the basic level, this is exactly what it means. So essentially it says if you have 3x minus 2y plus 6z is equal to 12, and minus 2x minus y plus 4z equals 15, or x minus 5z equals 4, then basically we're going to have a column for each individual part. Now, the way it works here for a matrix, it's pretty simple here. Let's again, we have the first column here, and it's in 16. All right. So the first column here, it would be, say, for example, this would be the x column. So the number of x's that you have here. So each coefficient has its own respective column, if you kind of want to put it that way. So x would be here, y would be here, z would be here, and then I put a little line here to reflect equals. So this line here reflect equals, and then this is the answer here that kind of goes next to it. So this is how we can represent systems of linear equations, and we're going to look at matrices here and be able to figure stuff out about how to solve for these particular guys. All right, so we're going to be looking at different cases here today about how to go ahead and solve for that. Now, what we're going to do next, of course, is we're not going to do this example. I just made up these numbers here on the fly. This could end up to be a really ugly answer. I have no idea what that answer is anyway. But let's go ahead and take a look at an example of a matrix. And we're going to want to set up, these are what we call augmented matrices because they add the answer to the right-hand side here. Now, let's take a look here at a system of linear equations. And what we're going to be doing here in this section is we're going to be doing the question number 3 here, which is talking about, so we're going to be talking about question 3 here is how do we solve linear systems using Gauss-Jordan elimination? Now, I'm going to be perfectly honest with you all here. All right, let's be honest. If I showed you how to do Gauss-Jordan elimination, all right, I could definitely show you how to do Gauss-Jordan elimination. This normally would take me about an hour to show you one example. All right, probably the first example. After that, it would take a much less time. But it takes like an hour and 10 minutes to show off that one example, and it takes quite a lot of writing for me to go ahead and actually met out. Instead, what we're going to do is we're going to take shortcuts, because shortcuts are what make us great. Kind of. All right, so we're going to take shortcuts here in order to do this particular thing, okay? Now, in order for us to do shortcuts, though, we need to, of course, get a problem, set it up appropriately, and be able to interpret our answer. So, nothing comes without a little bit of work. But you know what? It ain't that bad. Okay, so let's bring up our paint tool here, and let's go ahead and at least write out a problem here to start with. All right. Okay. Okay, so let's put up a problem here. We'll start off with some system of equations, and we'll see what we get here for this particular problem. Let's do it. Let's go with this. Okay. X plus y minus 2, 2x minus y, 5 minus x is 2y is 2 equals. Okay. All right. Now I'm going to point out a couple things here before we start with this. Go back to our handout here for a second. Okay. Now, in a matrix here, the first thing that we have to do is set up the matrix. Let's talk about setting up the matrix here. When we look at our example here from our question, to set up the matrix here, we're literally putting in every coefficient of x, every coefficient of y, and every coefficient of z. Now I'm going to add a note to this here so that way it's crystal clear about how we have to approach this. Again, note, all coefficients must be represented even if it is missing. And if it's missing, then put a 0 in its place. So I want you to take a look here at the last one here. We have x minus 5z. So literally you have x minus 5z. There are 0 y's at the end of the day. So that's why I put 1, 0 minus 5. Okay, so 1, 0 minus 5 is how we got x minus 5z. Okay, so even if you're missing that part, you got to read that carefully. Make sure you put those zeros in their respective places, even if they're not written down. Okay, so just like we did for the synthetic division, where every power has to be represented by its coefficient, same deal here. All right, doesn't matter. All right, so we can't skip. It's not how it works for matrices. So if I were to look at this example here, and I were to translate it over to this particular set of linear equations, let's write in our matrix here. So first and foremost here, you guys tell me, what should I write for the first row of this matrix based on what I see up here? What numbers am I going to put down here for my matrix? The first row. Just focus on the first row. Okay, so I'm going to put a big line here for the answer, by the way. So, what's the first row of this matrix here? Why don't you guys type that out in chat? 1, 1, minus 1, and 2. All right, good. That's correct. So 1 for x, 1 for y, minus 1 for z, because we have minus z, and 2. Okay, very nice job, Nicholas. That's correct. All right. How about the second row? Numbers are we going to have for the second row? 2 minus 1, 1. All right. So we have 2 minus 1 and 1. And then don't forget the answer on the right-hand side there, Bernice. We have the 5 there, so don't forget to put that 5 there on that right-hand side. Okay. That's why I put a big line there so I know where the equal sign is. And I just put the answer on the right of that. How about that third row? Negative 1, 2, 2, and 1. Okay, good. That's correct. Okay, so now we've effectively set up this matrix here. At least we know what the matrix looks like here after after just translating it from saying a linear system linear equations into this matrix guy here. Okay, now it's going to be on us to go ahead and solve for this matrix here. All right, now I want you to remember here we have x, y, and z here. Now I'm going to show you there's going to be a couple things going on here, but this will be the time where we're going to take out our calculator here. So let's take out our calculators. All right. And again, we're going to please follow me carefully here in order to enter in this matrix into your calculator. Okay, so we're going to go over things very, very carefully, all right? So, the first thing that we're going to do here, and so what I would like you to do here is we're going to hit the second key and the x to the -1 key. Okay, that will get our matrix menu here. So that's what I would like you to do here. I'd like you to hit the second key and the x to the -1 key. That will bring you to our matrix menu that should look just like this. Okay. Now, next I want you to scroll over to Edit. Okay. So I'm going to go over to Edit here and hit enter on matrix A here in this case. So we're going to hit enter on matrix A and we're going to get to a particular menu here. Okay. Now, you may have the new style calculator, you may have the old style calculator. The old style calculator, you may just see a number and with these numbers on top. But whatever, either case. All right. So before we move on here, of course, I'm going slow over this. Let's make sure everybody here is at this part here. Go ahead and type done in the chat if you have gotten to this part here in your calculator. Okay. Oh, my friend, you're done. Bye-bye. All right. Guess he was done. Okay. So I'm going to move forward here if everybody's got it. All right. If anybody's having issues, just stop me and then we'll try again. All right. Now I want you to look up top at what we have here on the screen. What we have here is two numbers. In this case, it says 1 by 1. Now, what's very important to note is what the matrix is asking you for here with these two numbers. And this is always how it's going to go here on your graphing calculator, regardless. Is what you're going to have here is you're going to have those two numbers here are going to reflect the number of rows by the number of columns. So it always goes rows by columns. This is always going to be true. So in this case, for our example, if you notice here on the screen, we have 3 rows for 3 equations. Okay? And specifically, we have 1, 2, 3, 4 columns. We're going to put 3 by 4 here in this case. Okay? So make sure you have 3 there for the number of rows, and then 4 here for the number of columns. Okay. Now, once a new guy has popped up here, we're going to go ahead and enter in all the numbers in our matrix. Just again, what the calculator likes to default is go 1 row at a time. So it's going to put in the numbers here. Again, be sure I'm going to warn you right now. Please use the negative key, not the minus key. If you use the minus key, you're going to get bad juju. All right? You have to use the negative key. All right? And you'll be asking me, why am I getting an error? Why am I getting an error? And be like, well, because you're using the minus key, not using the negative key. All right, so before I move forward here, I'm going to stop right here for a second. All right, I want you to type done in the chat if you have entered in all the numbers in the matrix here, just like I have right here. How we doing, E-Man? You okay? Okay. Make sure you have these numbers here. Need you to enter in these numbers here, okay? You need to follow along. Okay. And we'll move forward. Okay, good. All right. So, now the calculator at this point here is very particular about how very particular about matrices. For some reason, it's even more particular than it normally is. So one of the things I highly recommend you to do is what we're going to do next is we're going to hit the second key, so chat, and hit the mode key. I'm going to quit to the main screen here. This is very important. I normally do this all the time anyway, but hitting the second key and the mode key, this is going to quit us out to the main menu. The reason why we do this here specifically is because if you enter in anything, it's going to accidentally enter stuff into the matrix, and that is not what you want, okay? So obviously you want nothing entered into the matrix to avoid all that and to make sure that your matrix is perfect. Okay, we want to go ahead and quit out here to the main screen. Okay, so now what comes next? Well, what we're going to do is we're going to go ahead and we're going to go back into our matrix menu here again. So again, hit the second key and the X to the -1 key, all right, to get back to your matrix menu. All right, so let's do that. Okay, this time though, I do want you to go somewhere else. We're going to scroll over to the math menu, or the math submenu. Go over to math, really. Let's go like. We're going to scroll over to math, okay? That's what we're going to do, right? Now, we're going to scroll up or down, whichever way you want, doesn't matter, but we're going to go over to, I'll go over here to letter B. So this is where we want to go here. I'm going to scroll to B, which says RREF. Okay. Now, RREF stands for row reduced echelon form, but this is what it is. So that's and then hit enter. Okay, so this is what you should see here so far. Would mind possibly having a down arrow next to the RREF? Wait, what? I'm so confused. Okay. We just have REF on the screen. That's all we have right now. Okay, we're all good. Okay, all right. Whew. Thought I lost you there. All right. So this is what you should see here on the screen. Okay. Now we're going to do one more thing here, or maybe a couple more things. All right. So once again here, I want you to hit the second key, and I want you to follow that by the x to the -1 key again. Okay, so we're going to go back to that menu, the matrix menu here. So second x to the -1. And now you should see this at the very top. That same 3x4 matrix that we had made from before. Your calculator will automatically save it to what you see here. So that matrix that you made from before, it should be sitting there without too much trouble. Now, what we want to do is we want to call upon that. So if you see there, it says underneath names, it says A is 3x4. We're just going to hit enter on A. Okay, so hit enter on A, number 1, A. Okay. Underneath names, so we'll just hit enter right here. Okay. So this is what you should see on your screen, just like so. Okay. Now, not quite done just yet. Okay. We're going to close those parentheses here. All right. Now you're probably wondering why I'm closing the parentheses here. Is because you can do other things with this afterwards if you need to. Okay, such as convert the answers to fractions and whatnot. That's certainly possible in these cases. So, and then we'll hit enter after. Okay, so and then we'll hit enter after that. All right, so let's hit enter one more time. Okay, I'll show you how to change this up here. But does everybody have this? Okay. If you don't see it on your screen necessarily, you can hit the right arrow to go ahead and scroll over to see your rightmost column there. It will allow you to do that. Okay. But I want to be sure that everybody has these numbers here, at least in decimal format, to start with. Please type in done in the chat if you have this matrix here, this subsequent matrix. See if the others got it. Right, Jess got it. Okay, good. Brandon, you good? Okay, cool. All right. Perfect. So, I'm not going to write in the answer just yet because we're going to make one slight modification. So this is for, again, trying to streamline this as best as possible. If you do see decimals here as part of your end answer here, you're like, you know what? I don't want to look at decimals here. You know, that's not something I want to see. Well, here's a way you can get those decimals here to show up as fractions. Now, as you're already aware of, you know how to get fractions to you may be already aware about how to get fractions to show up on the calculator. If not, that's okay. What we're going to do here is we're going to hit the second key. I'll just put this chat here. We'll hit the second key, and then we'll hit second key and enter. Okay, so hit second key and enter here. Second key and enter. And it'll again bring up the exact same thing that we entered in before. Okay, so your previous entry. And then we want to hit the math key. Okay, so we want to hit the math key here, which is right below the alpha key. And then number 1, which is a fraction. And then hit enter. Okay. And then hit enter one more time. And now, bada bing, bada boom, hey, we got some answers. All right. All right, let's make sure everybody has this on their calculator. Type done in the chat if you have this on your calculator. Okay. Khadija, we good? Okay. All right. Let's move forward then. Okay. All right. Okay, so let's write in our matrix that we have here. Okay. So I do want to write this in, and then we need to talk about the results here. Okay. So here we have, this is our resulting matrix that we have here. Okay. Let's talk about our resulting matrix that we have here. Now, the resulting matrix that we have here has a significance to it. As we mentioned here before, we have our first column here, which is the X column. The second column is the Y column. And the third column is the Z column. So again, you have X's, you have Y's, and you have Z. And then you have the answer matrix, answer column there, sorry. So basically what this means is if you look at the first row with 1, 0, 0, and 7/3, this basically implies that X, again, X is equal to 7/3. Since we have 0, 1, 0 for the second row, that's Y is equal to 2/3. And we have 0, 0, 1 with the 1 here on the answer, so that means that Z is equal to 1. And in this case, that is going to be the final answer to solving for X, Y, and Z for this particular problem. Are there any questions about that? Any questions about that before we move forward with the next example? All right. So let's go ahead and do the next example here. Okay. And again, we just want to go ahead and make sure that all the numbers are in the right places, and then set up our matrix, and see what we get here. So this time here, I'm gonna write down an example here. I'm gonna have you guys try it. Now that you have the steps on the calculator here, now I want you guys to try it out for yourselves. All right? It's important that you know how to start from the ground up these problems. Again, pretty much all these problems here will revolve around doing something akin to this. So let's put down another one here. I may throw a little curveball here or there, by the way. Okay, there we go. There's our system of linear equations. All right, so the only thing I'm going to help you out with here is setting up this matrix. All right, so let's set up the matrix here. Can anybody give me the first row of the matrix? What's the first row of this matrix? Oh, there we go. Good, good, good. 1, 0, 3, 2. 1, 0, minus 3, 2. Good. Again, minus 3 with the z here. Be very careful about that sign. Oh yeah, that should be minus 2, guys. Got the minus here. I think everybody skipped that for a second. Minus 2 there. Careful about the signs for each number, guys. Remember to read each one carefully. So 1, 0, minus 3, minus 2. Okay, minus 2. What about that second row? About that second row? What's that going to be? 2226, okay. All right. Completely agree with you. 100%. All right, what about that last row then? Two, 2, 3, 10. All right, good. Okay, good. Okay, so now that you have this set up as a matrix here, now you need to set this up on your calculator. You can overwrite your your matrix A, by the way. You just have to edit the old matrix. So let's have you guys give it a try. All right, let's see what happens. Okay. I'll give you guys a minute. I'll give you guys a minute or two to see what you get here for your final result after reducing this matrix down. Then we'll compare results, okay? throw it in there. I was the tie-breaking vote with yes. I'm gonna give you a little time to give you a little time to do that. All right, some of you guys are done. All right, we'll wait for a couple others here. Tyrannica contributed 100 channel points for that. Gotta use them sometime. I suppose so. Joseph. Joseph says hydrate. Which one do you want me to hydrate with, Joseph? That's the question here. I got Gatorade with caffeine kind of drink. I got the Frappuccino, and I got regular. I got water. You get to pick, Joseph. It's only fair. Water? Okay. Thank you. All right. All right. Let's see if people got it right. All right, Jess, you get to pick. Okay. Pick the Frappuccino here. Let's shake this up a bit. This stuff off the bottom. There we go. Thank you very much, Jess, for the hydration. All right. Okay. So, let's see if we got it right. Okay. Let's do a prediction. A prediction is where you can bet your channel points. So, let's put a prediction here. So I'll give you guys a minute. You guys can bet your channel points. Remember, that's a bet, your channel points here. So you can bet your channel points here, and the question is, did I get it right? And you can bet your channel points here. You can bet as much as you want. So again, you don't have to. You can bet small amounts or big amounts. Well, it doesn't matter really. Oh. Jeez! Holy smokes! 8,000! Woof! Woof! Alright, let's see if we got it right. I don't know, but we're gonna find out, right? Okay! And we'll see how the prediction goes. Alright, let's go ahead and do it. So let's go ahead and set this up here. Alright. We'll hit second and matrix here. Alright, so we'll go ahead and go to edit. We'll edit this matrix that we have up here. Let's put in the numbers here appropriately. Still a 3x4 matrix, so we have 1, 0, -3, -2, 2, 2, 2, 6, and 2, 2, 3, and 10. Okay, so we want to quit out of this, second and mode to quit out. I'm gonna hit second and matrix here once again. to math. We'll go to RREF here. Then we want to call upon the matrix menu once again. So second and the matrix menu again. Call upon matrix A here. And let's see what happens. We'll put a fraction on it just in case. So fraction. Don't know if this will be fraction, but hey, find out. Okay. So this is the matrix that we had come up with. All right, so hopefully this matches the matrix that you got. Okay, so the matrix resulting here, 1, 0, 0, 10, 0, 1, 0, minus 11, and 0, 0, 1, and 4. Alright, so your final answer here should be x is equal to 10, y equals negative 11, z equals 4. Okay? There we go. Alright, and I hope you got the same final answer that I did. Let's see. Go ahead and type done in the chat if you got the same final answer that I just got here on the screen. So I hope you got the same answer that I did now that we've tried one on kind of more on your own-ish. All right. Ooh, that's good. That's good. All right. So that means I got to choose a prediction outcome here. All right. Because the prediction outcome was going to be if got yes or no. So the answer here is, did I get it right? And the answer is yes. I got it right. Okay, very good. Because if I messed it up, then it would be no, and everybody loses channel points. Everybody would have been super sad. You guys bet a lot. Okay. All right. Nice. Okay. Let's go ahead and are there any questions? Any questions, by the way? Any questions before we move to the next example? Big risk, big reward. You got that right. It's too true. Too true. Right. See how easy these problems are? Are these problems a bit easier now? Now they're not as intimidating, right? Hopefully that's the case. All right. Hopefully they're not too bad. All right. I'm gonna write out one more example here, and then I'm gonna have you guys give it a try again, and then you'll just need to make an adjustment or so. But this time, I'm not gonna help you with anything. I'm just gonna write out the problem here. You guys are gonna do it, and I'm gonna get an answer. So that is going to be this last challenge here for this guy. So yeah, why not? All right. Oh, I am. Take them back. Took them back. Oh no. Okay. All right. Make sure I'm reading off the right one. I want to. There's very specific problems I want. So hence why I'm being very meticulous about the problems here. Unfortunately, it can't be all like crazy with numbers problems. Otherwise, it does turn to be really. BC equal. Okay. All right, good stuff. All right, there we go. That's going to be our system of linear equations. I'm Jeff Bezos, rich in channel points. Now, if we can be Jeff Bezos rich in real life. Okay, maybe not. I have hundreds of billions of dollars. Yeah. I'm pretty happy with the money I have. I'm pretty happy. I can't complain. So, um, all right. So, let's have you guys give this a try. Okay? And one day I'll take over the world, you know, with in warehouses, and I'll have billions of dollars. Mwahaha. Okay. One day. Now, if you gain $1 billion, then okay, I'm fine with that. You guys can make all the coin. All right. You can you can have the paper, you can have the paper bill spray, be like, make it rain singles. Yeah. Make all the Doge all the time. Have you guys give this a try here. I'll give you a minute or two to hopefully get this going. What is Dogecoin at now? Dogecoin, I don't even know anymore. Dogecoin is at 23 cents. Okay, 23 cents. Looks like the meme coin is making its way down. Was it like 75 cents? Meme coins are memes. Memes are dreams, ladies and gentlemen. Are dreams. Jess says to hydrate. Okay. What am I hydrating with, Jess? What am I hydrating with, Jess? You gotta tell me. Jess says done. Okay. All right. So far, so good. Starbucks. Okay. Done. DJ done. Hey, DJ. You couldn't. Khadija didn't count, so DJ had to come out. All right. That's fine. The computer died on one end. You're like, I'm gonna go to the other. All right, anybody else that's done here? Hopefully you got this down. Just wait for a few more people here to tell me if they are done, and then we're going to do this out here together. I'm going to see what we got. All right, Bernice is done. Okay. All right. Okay, let's go ahead and give it a shot. All right, so the resulting matrix that you should have here is 1, 1, 1, 1. All right, Brandon is done. Good, good. So you should have 1, 1, 1, 1, 2, 1, minus 2, minus 1, and 0. 1, minus 2, minus 1, minus 2, minus 2. Last row here should be 3, 2, 1, 3, 4. So in this particular case, let's at least put this off to the right because I'll need this matrix here. So in this particular case, let's go ahead and put this into the calculator. So second matrix, and go over to edit. This time though, we have 4 rows and 5 columns. So that's the big key difference here is we have 4 rows and 5 columns here as opposed to 3 rows and 4 columns. So I put in all the numbers here appropriately, exactly as what was intended. 2 minus 1 and that. 1 minus 2 minus 1 minus 2 is 2. 3, 2, 1, 3, and 4. Okay, so that's what we have here for this. All right, and let's see what we get here when we reduce it down. So second mode to quit out. It's second in matrix here. Go to math. Go to RREF. We'll hit second in matrix here again. Call upon matrix A. Go ahead and put in that parenthesis like so. And we'll go ahead and hit fraction just in case because we don't know. And there we go. Got our answers here. 1, 0, 0, 0, and 0, 1, 0, 1, 0, 3, 0, 0, 0, and minus 2. So we should have our answers here. Our answers here are going to be, let me clear this out. Our answers here are going to be W equals 1, X equals 2, Y equals 3, and Z is equal to minus 2. And that's our final answer for this problem. Good stuff. All right, hopefully you got the same exact answers that I did. If you did, nice. If you didn't, boo. You might have to try that again. Right. Let me know if you guys got questions before we move forward. Hopefully less sad bananas. Okay. Nope. All right, let's move on here then. All right. So using this same vein about how we solve for matrices here, I'm going to do the same thing here once again, by the way, just with different sets of problems. So let's go to the next handout here. That's not the handout I wanted. And let's go to the other handout. Okay, so let's look at 6.2 here. We'll talk about, we're not going to do 6.3 here today, but 6.2. 6.2 is, again, the reason why 6.1, 6.2 go together really well is because we're pretty much going to be doing the same exact thing we just did for these 3 matrices. says, what is a square matrix? A square matrix is a matrix with the same number of rows and columns, excluding the answer column. So if you exclude the answer column, if you have three equations and 3 variables, that's considered a square matrix, okay? You just exclude the answer column and you say, okay, well, that's a square matrix. Now, what we're going to be talking about here are 2 concepts that we talked about here back in Chapter 5. Back in Chapter 5, when we did linear equations, we saw how we could get no solutions and infinite solutions. And that's exactly what we're doing here in this particular section, is no solutions and infinite solutions, and how we can find that here via matrices. Because at the end of the day, there's still linear equations, and they still can have that happen, okay? So again, inconsistent systems, as how do we find inconsistent systems, i.e., again, a no solution, i.e., no solution. We just have a different fancy name for it in matrices. The trick is to look at the last row of the reduced matrix and see if we have all zeros and a 1 at the end, or any other number for that matter. We'll also look at dependent systems, which is, i.e., infinite solutions. However, infinite solutions here is a little bit different. We'll talk about that. At least how we have to express infinite solutions. Okay, so we'll look at that here, is to make sure you have all zeros after reducing the matrix. Okay, fine. All right. Now, let's take a look at an example of each, and we'll see exactly how that works out. Which one I want to do? Okay, let's do that. Actually, I have to ensure that that actually does. I need it. Make sure I chose. Give me terrible problems. All right, there we go. That's a good problem. All right. All right, let's do this. All right. And then we're going to have this last one here, x plus 2y minus 3z 5. All right. So what I want to show off here specifically is what happens when we reduce this matrix here. So 5x plus 12y plus z is equal to 10. 2x plus 5y plus 2z is equal to minus 1. X plus 2y minus 3z is equal to positive 5. So setting up the matrix here, just what we talked about before, isn't too hard to figure out. It should be pretty straightforward. Now that we have that pretty comfortable with that. Alright, so here's the matrix. Not, nothing too groundbreaking, at least from where we're sitting. But let's go and see what happens when we reduce this down in the calculator. Alright, so what happens when we reduce this down in the calculator, and why would this be considered not the greatest problem in the whole wide world? Again, let's edit the matrix back again. We'll go to a 3x4 matrix here again. So 2, 5, 2, minus 1, minus 1, 1, 2, negative 3, and 5. Okay, so this is our matrix here. I'm gonna second in mode, quit out of there. We'll hit second in matrix, go to math, go to RREF again, and we'll hit second and matrix here again. And we'll go to names. Oops, let's just go to names. And we'll do fraction, math fraction. Okay. Now, let's take a look at this resulting matrix that we have here. Okay. Let's take a look at this resulting matrix. And this is going to harken back to something that we had talked about previously in chapter 5. So then you'll see why this makes sense. So here's the issue. The issue for this particular reduction, after we reduce it down, we plug it in, we do the whole thing, we do all the things that we're supposed to do. And at the end of the day, when we reduce it down, we get this row here at the bottom. Okay? Now, the bigger problem here with this is that if you remember how we talked about no solution, we said, all right, back in the day, we said, all right, you know what? We said, okay, if we run into a situation where like 0y is equal to like 2, then this would be indicative of no solution, because we said 0 times anything is equal to 0. So how the heck can y be any number here? It will never equal 2, okay? 0 times anything is 0. So this was again indicative of no solution. We knew that again y wasn't possible to find a y, whereas going to satisfy that at the end of the day. And with this matrix here, it's exactly the same thing. The same thing is going on here, just like it was back in chapter 5. In this case, we're just dealing with an extra variable or variables. Okay, maybe we're dealing with 2 extra variables instead of, with a w and z. Maybe we're just dealing with 1 in terms of z. Regardless, what this is going to show you is normally we would get 0, 0, 1, and then a number. And that would be indicative of z is equal to some random number. All right, in this case here, we don't have a 0 here. We don't have a 1 here on z. We have a 0. So this part here would indicate we'd have 0z. Now in this case here, what does 0z equal? 0z equals to 1. Okay, so we run into the same situation that we did here back in chapter 5, just with z instead of x or y. But it still has the same exact meaning as it had from before. If you get that 1 on the right-hand side and a bunch of zeros on that left-hand side there, like you have there, for that last row after reducing it down, well, guess what? That is not going to work out the way you wanted it to. So, at the end of the day, this is going to be indicative of an inconsistent system or no solution. So be inconsistent. Or again, you'll see the circle with the cross through it like so. Either way, that is what it'll come out to be at the end of the day. All right. Okay, any questions about that? So I just need to show you an example of that because it's not, it looks pretty clear, but it's not super clear at first. So, no. All right. All right, let's take a look at another one here. Sure. All right, let's look at another one. All right, so this next example here will more exemplify the next question. So what about infinite solutions, and why are infinite solutions a little different? Well, we need to look at an example here for that. So let's write out a system of equations, see what we're working with. Okay. This should be should be. Okay, that's fine. Okay. Okay. Let's see. Alrighty. So here is our 3 equations, 3 variables. Alright, let's see what happens when we reduce this one down. Again, setting up the matrix here is not the hard part. Okay. So let's set this up here, and let's see what we get. Alright. Alright, so here we have 5, 8, -6, 14, 3, 4, -2, 8, 1. Okay, there we are. Perfect. Alright. So we'll hit, again, second mode. We're going to hit second and matrix. And we'll go ahead and go to math. Go to the letter B. Second and matrix again. Go over to names letter A. We'll hit math and fraction just in case. And let's see what we get here. Okay. Now, things are now noticeably different in this regard. Let's talk about this part here. So this converts over to 1, 0, 2, and 2. This is 0, 1, -2, and a half. And 0, 0, 0, and 0. Alright. So this being the second example here, again, I want you to take a look here at the very last row once again. The last row here says 0, 0, 0 with a 0. So like the last problem we have, like say, again, we would normally get the answer for z here in this particular instance. However, that is not what's going on here. In this instance, we're going ahead and we're saying, okay, well, we're getting 0z is equal to 0. Now this would clearly indicate infinite solutions. However, what's important to note is that we can't be, how would I put it? We can't be really willy-nilly about the solutions for this, okay? So you have to actually express infinite solutions in terms of what the matrix gives you, okay? Because infinite solutions here are going to be dependent on the other variables involved in the problem. That's something that you have to be very well aware of. So the question is, how do I go ahead and say, okay, well, what is this going to be at the end of the day? How do I know that this is going, how do I know what this is going to equal to? Well, everything in this particular problem here is going to revolve around the variable z. If you take a look here, z is essentially can be any number you want it to be, because literally 0 times any number is equal to 0. So if we were to write out a solution set here, and I'm going to actually make this bigger. So if we were to write out a solution for this, essentially I could put in any number in for z. So I would have, say, something something comma z. That's what I would have out here. Now, let's take a look here at the other two rows, though, because they do have representation in terms of z. For example, I could rewrite this equation here. Again, remember you have the x column, the y column, the z column, and the answer column, and the equals here. So you technically have x plus 2z equals 2. And you have y minus 2z equals a half. I mean, technically that's true. Okay, you have that going for you here. Which means that essentially you can write x and y also in terms of z. You can subtract by 2z on both sides here. And so if you wanted to express x in terms of z, you would have 2 minus 2z for the solution for x. And you can add by 2z here on both sides for this. And you could technically have 1/2 plus 2z as your answer for y. So if you notice what I did here, x would be 2 minus 2z, y would be 1/2 plus 2z, and z can be whatever number it wants at the end of the day. Again, that's because x and y are totally dependent on what that last answer is going to be. Okay, so that's, again, very important to note here, is that you just start from that last number and then kind of work your way backwards to get it to everything in terms of one particular value. Okay. So I guess I should put this down, because I need to say that. Oh, yeah. Put the answer entirely in terms of one variable where you have infinite answers. Okay. This is usually z, or the last variable. Sometimes they'll ask you for other variables, but still. That's pretty much how that'll work. Are there any questions about that? Usually that's the toughest one here. What's my favorite matrix? The identity matrix. That's an easy one, Normal Monkey. How are you, man? Identity matrix is the easiest matrix. I don't have to worry about it. Matrices without eigenvalues and eigenvectors. I haven't done that stuff in years. I haven't done that stuff in aeons. It's been 20 years since I did eigenvalues, eigenvectors with like deltas across the diagonal. Oh my gosh. You guys want another example, or are you guys good? Oh man, it's too funny. One more? You got it. Nicholas is like, one more? You betcha, buddy. You betcha. 100. Hey, look, I follow you. Look, I know you guys follow me most of the time, but I like I said, I listen to you guys. So, Let it not be said that there wasn't a teacher who actually listened to what you wanted. So, all right, this isn't like, yeah. I'm listening to all of you. I promise. I promise. All right. Let us put everything. Okay. Mas por favor. With pleasure. Now, see if I ask you that, Lysedrena, of like, do you want more homework? And you're like, mas por favor. I'm like, no. It's like, you have answered correctly. I would just, I would look down. I'd look down and you'd be like, ah, qué lástima. Lo siento. You're not sorry at all. Are you sure about that? I am a math professor after all. I have to have some kind of mean streak in me. See? All right. Here's our all languages are welcome. How much I will understand of all languages is a different story. Like if I speak broken Japanese, like I can speak broken Japanese. So, okay. Yeah. What's wrong with you, Khadija? Betty, Yawa. Betty is both बदतमीज. बहुत बदतमीज. Since when it was, since when, Khadija, since when is it wasn't? That's the question. That's the question you have to ask yourself. Since when it wasn't that bad. Totally, totally demakhrabe, indeed. बिल्कुल बिल्कुल दिमाग खराब बिल्कुल my mom likes to tell me bichara beta bichara bichara beta basically is like why why son why or like it's like an term of exasperation like oh why oh man Demakharabe means what's wrong with your head or what's wrong with your brain so and Kyawa means what's wrong. Everyone's starting like that. Look, just like I understand a little bit. I didn't say I don't know. I'm like a polyglot and I know like every language in the book. I just understand a little bit of like languages here and there outside of English. Okay, mind you, polyglots, they're a different story. They're amazing. Like no cap, they're really really good at what they do. Look, look, it's like that time where my mom and her friend, like the most embarrassing thing I ever saw. All right, true story. Most embarrassing thing I ever saw was like we were at like a Sam's Club or Walmart or whatever, and basically my mom and her friend were talking, and they were just they were talking like, oh, we want to get a good deal at picking up something from the prescription thing, like, hey, can you throw me a deal? Like they're trying to scheme with each other in Urdu, and basically the guy behind the counter is like, just looks him straight in the face, like, I can understand you, and I'm like, yeah, kind of like he kind of looked at him. I was looking at him the whole time. He's just kind of nodding his head. I'm like, all right. I'm like, I had to turn to my mom. He's like, he understands you, right? And he's like, my mom's like, and he's like, she keeps talking. I'm like, he understands you, right? It took her and a friend a minute to realize that was anything that they were gonna do. It wasn't gonna fly, and they weren't gonna get a deal on whatever they wanted. It just didn't matter. It just didn't matter. I'm like, I just was embarrassed for them at that moment in time. Completely embarrassed. I'm like, you guys are terrible. Je suis baguette. Oui, oui. I see. Well, that's what Khadija had put in the chat there. That's Urdu right there. I love that. Yeah, but you know what? I speak a little bit. I don't speak it fluently. Obviously, there's no way I'm going to. Even though I've raised up with it technically, but still, I can't speak. I used to when I was a kid, apparently, but that was when I was like 3, and you could literally learn like any language at 3 years old. So, um, don't know how many times I've understood what people are talking really saying about me. Yeah, I basically stopped caring. People are gonna talk like, oh, you could understand me, like, it's like, yeah, I can. Like I'm sitting right here. I know what you're saying. In a nutshell, I pretty much know what you're saying. You guys, yeah, you fool me. Yeah, I speak Japanese. I speak Japanese enough to order pizza. Maybe. I mean, all the Japanese need just order pizza. Pizza's heck of expensive in Japan, though. So, could you watch the anime without the subs? Some parts, not all parts. Some parts you can watch without the subs, but definitely not all parts. I would say probably if I were to give myself a percentage, Blink, I'd probably say maybe without the subs, I could probably watch like 20-25% maybe. Yeah, so it's like I'm not gonna sit here and be like, yeah, I know everything. Like, trust me, no. No, I still need the subs. And by the way, there are very few dubs that I'll ever watch. So yeah, it's always subs for me. If you're gonna watch anime, it's always subs. Look, some anime is just like really complex Japanese. So, but yeah, like 20-25% maybe at most. So I'm not gonna claim I'm like the best. So that's false advertising. All right. Link, you can learn Japanese too, buddy. If you're really interested, you can learn Japanese. It's not as bad as people make it out to be. The hardest part about Japanese, without question, is kanji. Kanji, it by far and away, is the hardest thing about Japanese. All right, like actually reading kanji and stuff like that is absolutely brutal. But take away kanji, and just you're talking about like the speaking stuff, it's not the worst. Okay, it takes a little bit of getting used to though, because it's a different grammatical structure than that of English or any other language or other languages. So, because you put the verb at the end of the sentence as opposed to in the middle of the sentence. So, okay, let's go ahead and put this in here. All right. Look, why not try? Blink, if you're interested in something, I'm going to be perfectly honest, and this goes with for everybody in the chat. It doesn't matter for all of you guys. Let me be perfectly honest with you. I got my master's degree in mathematics, okay? And then after I got my master's degree in mathematics, I moved to Japan for 4 years. I didn't use my master's degree right away in mathematics. I went to go teach English in another country. And let me be honest with you, why did I go and do that? The reason why I went and did that is because I wanted to do something before I was old enough to regret a decision of not doing that particular something. I said I really wanted to go to Japan. I wanted to live in Japan. I said I want to do this before I die. This is kind of like on my life list, you know, I want to do that. And I'm like, hey, if I'm going to fulfill that goal, I'm going to see it all the way through regardless of what I have in front of me. I mean, I could have gone and got a math job after I was done, but you know what? I'm like, I want to do this, you know, so I don't have any regrets. And I'm very happy that I did. So if that's something on your list that you want to do, then by all means do it. You know, don't make sure that you don't have regrets that you missed out on something. You know, there's always FOMO, you know, fear of missing out, but especially when it's something that you feel really strongly or passionate about, just go ahead and do it. Okay? Make sure you don't have regrets of doing that particular something. So, you know, and you never know what's going to happen, but that's the beauty of it. When I went to Japan, I had no idea what I was doing. I didn't even know the language. I didn't even know nobody. I know nothing. You know, but I came out of there with wonderful experiences and wonderful memories. I don't regret. Depends. Locals are different from place to place. So in Tokyo, it's pretty indifferent. If you go to smaller towns, you have to mind your manners a little bit more. Really, at the end of the day, I was pretty quiet. So I'm like, you know what? I'm not really going to bother other people. But if you do, you know, if you accidentally do something wrong or bump into somebody, you say sumimasen, you know, you'll say that a lot. Say a lot of sumimasens, which is like, excuse me, a lot of times. But locals are pretty nice. Some locals are going to be, you know, they're going to be whatever. But you know what comes with the territory as well, Brandon. So it's not. I'm not gonna sit here and lie and says you know what's gonna come with the territory. Duolingo is a free trap, yeah. Using it to learn German, wonderful, wonderful. How many rows we got? 3 columns and 5 rows. Okay. This, guys, that's the one thing I want to encourage you to do. Do something in your life that you want to do for yourself. It doesn't matter about anything else. Before we go, and you like, you know, so you don't live life with regrets of doing something. That, you know, life with no regrets is a good thing. Yes. But yeah, do something. That way you're not regretting missing out later. So please, go ahead and do it. You know, experience it, have fun with it. I think if, like I said, if it's something you're passionate about, take it to the next level. Why not? Never a bad thing. One thing I always admired about Japanese people, very true, that Japanese people, regardless of what hobby it is, doesn't matter what hobby it is, they will take that hobby and they will always do it at 100%. It's always 100%. So any hobby that they do, it's always at 100%. They have that same kind of mentality of no regrets. But like a common hobby in Japan was like photography. And when I say, okay, if your hobby is photography, and I would talk to a lot of clients, common thing I would always see, there's always a common thread between all of them, is that they would go all out. Yeah. And that's what your sister-in-law wanted to do. She like, I want to teach in Hong Kong and Thailand. I said, okay. I want to be there. I want to experience it. I want to do it. And then that's it. I get it out of my system. I go no regrets. I come over here. I do what I want to do after that. Exactly, Lysaidana. Exactly. Exactly. Like I said about the Japanese, when they go 100% for like photography, they buy like the top of the line Nikon stuff, the whole 9 yards. I asked them, okay, what do you got? They got like the top of the line Nikon 9000 series cameras. It costs like $1,000. They got the tripods, they got the filtering lenses, they got like the bags. I'm talking going super ham. And they go out and do it. I'm like, wow, all right. Oh, no complaints. If you're gonna do it, then go ham. All right. It's fish tanks. Yeah. You're like, I'm gonna go ham because this is what I like. This is my hobby. This is what I want to do. Okay. You have no regrets when you walk away. Okay. Let's go ahead and reduce this down, by the way, as I've been meaning to do this for a while. Sorry. But, you know, it's a life lesson that I learned, and it's a very valuable one. I ain't gonna lie. It's a very valuable life lesson that I learned. RREF this. And it, to me, even to this day, is one of the most valuable life lessons that I learned. Alright, let's take a look at what we got here for this resulting matrix. Our last example here. I told you, this class isn't just about mathematics. No, as the description in my profile says, math can be really dry and boring. No, but learning other things along the way isn't so bad either. So, we gotta endure this together. Let's at least learn a little bit more along the way. Yeah? That isn't so bad. Okay, let's take a look at our answers here, by the way. I do need to at least express those. Alright, so in these cases here, yeah. Alright, so in these cases here, what we have is we have X, we have W, X, Y, and Z. And we have the answer here. Now, if you notice here, there's no last and final row here. Alright, I want you to notice the problem here. There were actually 3 rows and 4 variables. So in a sense, one variable is kind of left over, okay? One variable is kind of left over here. That variable here is Z, all right? So we don't have a row of zeros here on the bottom. But since we have more variables than rows, then essentially we are still going to get infinite solutions, okay? We have more variables. So we have more variables. Right, let's just type it out. I don't know why I'm making it so hard. Okay, what the? Second? Alright, you know what? I'm in a good mood. Alright, I'm in a good mood. Going super ham. Alright. That's right. That's right, ladies and gentlemen. That's right, ladies and gentlemen. We went Comic Sans. That's right. I went Comic Sans. There you go. I went the super cheese route. Alright? Hopefully you guys are happy now. Okay, so what we get here is that we're going to have z here to be our guy. So again, z is going to be our infinite amount of answers here. So we have, let's take a look at what we have here. We have x minus z equals 3. Again, we want to put everything in terms of one variable. So y minus 5z is equal to 5. And, oh, that should be, I'm sorry. Why did I put x? I'm so sorry. I did that wrong. I forget that the first variable is w. W minus z is equal to 3. I always forget w goes first in these problems. X minus 5z equals 5. And then y minus 3z equals 4. Okay. So if we put w here, w will equal 3 plus z. X equals 5 plus 5z. And y here is equal to 4 plus 3z. So that's how we're going to express this answer here. 3 plus z, 5 plus 5z for x, and 4 plus 3z. And there we go. That's our final answer for our dependent system. And that's it. GG. Khadijah's like, GG, I'm going back to sleep. Khadijah's like, GG, easy clap. Easy clap pillow. So the way we know that is basically based off this note here, Ryan. If you have more variables than rows, it's going to be indicative of infinite solutions. So what we arbitrarily did is we took the last variable of z as our infinite solutions here. And then everything else is in terms of z, as you can see here for our final result. Right? So that's what we kind of arbitrarily did here because of that little fact with more variables than rows. Just take that last variable, you say, okay, there's going to be an infinite amount of those guys. All right, let's put the rest of the answers dependent on that particular answer. Yes, we actually have I'm sorry. We have 4 variables. In this case here, we have 4 variables and 3 rows. Right? We have 4 variables and 3 rows, right? That's what we have here in our beginning. 1, 2, 3, 4. 1, 2, 3. Yep. Yeah. That's correct. So from the very outset of the problem, we could make that assumption that z is going to be infinite, but we just have to find out what the other variables are in terms of z. Any other questions? Posture check to Jets, thank you. Knee? Khadija says knee. Like the knights who say knee? I mean, we could cut down trees with a herring. We could do that, you know. We could totally do that. Why? Why you bully me? Don't worry, I know you'll forget all about this as soon as this is over and that you put your head on the pillow and fall asleep. This will all be a fever dream. No in Spanish. I bully everybody. You can bully me too, by the way. That's only fair. Remember, I give as much as I should get as much as I give. So there you go. Did no one else get the Monty Python reference? Yeah, I was waiting for somebody to pick up on that. I almost watched that movie at least 30 times. He's amazing. I haven't seen it in a while, but still. It is but a flesh wound! That's correct! It is but a flesh wound. Haha, share is lame. That's fair. My butt is also big and I cannot lie. See, I can insult myself. It's okay. as long as I bully myself, it's all good. Finding Jesus' nightmare is true. I know all that time you spend sitting in your chair. I'm telling you, it's just like finding jeans can be rather tough. You gotta have the flexi jeans. Not too bad with them. Stuff you can pick up from Walmart or something. Yeah. That's where I usually buy my jeans. I buy them for like 30, 40 bucks. I'll get them like once every 5-6 years. If you're bullying, just laugh and continue to bully yourself in front of the bullies. They'll think you're insulting you. Yeah, I would give. If we're gonna be serious about bullying, yeah, I was bullied a lot in high school. Pretty much every year for 4. So I've over time I've learned to laugh at myself and have a nice time with others. Trust me, none of the things I ever say I actually mean. Unless I'm being dead ass serious or I have a really good reason to. I really I really honestly mean none of the things I say. In terms of like insults and stuff. And like I said, it's always a two-way street. So it's not just me just saying stuff. You guys are more than welcome to flame me as hard as you like. That's all you like. Do try to make fun of my face because I had acne, and I probably would say, "Yeah, dude, it looks like a constellation." I probably say, "Hey, why don't you take a look at my back? I got the Mona Lisa painted back there. There you go." I had to scream out. I think that that's what makes people great. Let's be honest with ourselves. That's what makes people great is the imperfections that we have. There's no such thing as a perfect person. Everybody's imperfect in some way, and I think that's what makes people absolutely outstanding. Doesn't matter how much airbrushing you do. Doesn't matter how much makeup you put on. It doesn't matter about how much touching you do. How whatever you do, there's always going to be imperfection, and I don't think that's such a bad thing. You should learn to love your imperfections as much as the parts that do work rather well. So, far be it for me to say that I'm perfect. So, I could tell you that right now. The universe was created by an imperfection. Yeah. Nothing's perfect, so it's okay. Just the wise indeed. I'm just living in it, and I happen to like it. That uncomfortability, that kind of chaos that people don't like because of the amount of imperfection. I like it. I love it. I thrive in that stuff. It all started with My Big Bang, says Comash. I don't even know what to say about that. Have I ever been in Silicon Valley? I've driven by Mountain View, because my dad lives out in the San Francisco area. Um, so I haven't been. I've been to San Jose, of course. But yeah, I mean, I haven't been to like Mountain View or stuff like that. But I mean, honestly, oh, I thought you been to. I thought I read been to Silicon Valley. I oversaw. I only saw like one episode, but it's pretty accurate. At least the housing situation, when I saw in that one episode, is pretty accurate. It is that expensive and it is that cramped, and really, you know, I don't know what it is. I'm gonna be honest with you, and I know that I've said this before, and I'm just be like, I'll just be straight up chill with this. But I've been to San Francisco, I've been to LA, and I wasn't impressed by LA. I wasn't impressed by LA at all. LA was not my kind of city. I just thought LA was really, and again, people from LA. I've talked with people from LA, and they say, and some of them have differing opinions, but I'm like, LA just didn't do it for me. It just didn't do it for me. It was just really boring. I just really was incredibly bored in LA. I went there. It just didn't do anything. You wouldn't go by Beverly Hills, you go to the Hollywood things. I'm like, it's so dull. It's so dull. It's just like it's so dull to me. I don't know. It's not that exciting to me. Now, if you probably can find those nooks and crannies in LA that makes it exciting for you, great. And just trust me when I say this. Don't let my opinion skew your opinion. You experience it for yourself and make your own opinion. Okay, that's important. All right? That's how I felt. Now, I haven't been in LA in quite a while. Maybe things have changed. Maybe things are different. I don't know. But I hope you have a wonderful time. I remember there's one block that's nice of LA, and the rest is. I don't know if that's true or not. I don't think that would be true, but there have been issues going on. At the end of the day, you should have fun, and you should make your own opinions about what you think. Because again, don't let other people try and taint your opinion about. I'm just telling you my experience, but it's not fair to your experience, because you should have an open mind when you go there, and then have a great time. That's all I can really say, and that goes for any city you go to. Keep an open mind. Walk into that city. See what you guys think. If you guys like it, you're gonna like it. If you're gonna hate it, you're gonna hate it. If you're gonna be meh, you're gonna be meh. But just keep an open mind. It's always important that you do so that way you can experience it for as much as it would. The Pacific Ocean's really nice. One thing about San Francisco I can say is that the piers are really nice. The piers are really nice. Good night, Khadija. Have a good one. Good night again. Santa Monica, the Pacific Coast, Koreatown, Venice Beach. I was in LA last month and I had a blast. That's great. Listen, Brandon, I'm super happy that you had a wonderful time. Been to Venice Beach. Venice Beach was okay. I'm not a big beach guy, I'll be honest with you there. Alright. Alright, Gold Mash, you have a good one. I'll be watching that game in 10 minutes. Yeah, look, you go to Venice Beach, you have a nice time, perfect. That's exactly what you should do. You go to Koreatown, go to Pacific Coast. Hey, man, I'm glad you had an outstanding time, and I'm glad that it worked for you. What am I gonna say? I'm gonna say, oh yeah, no, oh you're bad because you went to this, that. Like, no, man. Have fun and just enjoy yourself. And if you get positive experiences out of it, then that's all that matters. That's all that matters at the end of the day. Positive experiences which you can take memories out of. And if you want to go back again, you go back again. Have another great time. Everybody has a different metric about what they think good is. So, in terms of visiting places. So, all right. Well, ladies and gentlemen, are there any more questions before we head out for today? Any more questions? Any more questions? And we're gonna probably head out, and we'll resume here with chapter 6 here for tomorrow. We're done for today. Yeah, Jess, look, it's past 1:50. Believe that. The time went by that fast. You guys make this time go fast because you guys make this time really fun and exciting. So, really appreciate you guys. All right, ladies and gentlemen, thank you so much. All right, let's go here. Thank you so much for coming out here to the stream once again here today. Okay, love all of you. All of you are fantastic, fantastic people here today. Thank you so, so very much. I really appreciate the time and energy you guys bring every single day. We're going to come back here tomorrow, same time, same place. And we're going to do some more of Chapter 6. Working our way through. Getting there. Getting almost done. There. Okay? All right, everybody. Have yourself a very wonderful day and afternoon and evening. All right, and we'll see you tomorrow. All right, and as always, everybody, stay safe, stay healthy, but most importantly, ladies and gentlemen, stay sane. All right, take care of yourself, everybody. Have a good one. All right, see you later, everybody. Bye. Bye, guys.